Good morning. Welcome to the final day. This is the Kruskal Wallis test. This is another non-parametric test. What? And this test happens to be the non-parametric counterpart to analysis of variance, specifically one-way analysis of variance. When did we use one-way analysis of variance again? When we compared more than two groups. So let me go down to the typed version. Okay. A pilot wants to buy a battery-powered radio as an alternative to his regular radios, which are powered by the airplane's electrical system. He has a choice of 3 brands of rechargeable batteries, which vary in cost. Sample data for each brand are obtained and are given below. The numbers represent the running time in hours before recharging becomes necessary. At the 5% level, test the claim that all 3 brands have the same lifetime before recharging. First off, note the sample sizes of each brand are different. Doesn't matter for this test. Okay, now this is a test for analysis. There's a counterpart for analysis of variance, but I'll be honest, it might be one of the quickest, most basic tests you're going to handle. All right, so just like the Wilcoxon rank sum test, you are ranking all the sets as one big group, put all the groups together. So, ladies and gentlemen, if you can literally just rank from low to high, you can do this hypothesis test. 25.9 in brand X is the smallest number overall, it gets a rank of 1. 26 gets a rank of 2. It's the next smallest number overall. 26.3 here in brand Z is the third ranked. Then 4, then 5, then 6, then 7, then 8, then 9, and 10, all the way down the list. And then the 18th and the 19th ranked numbers happen to be 30.3. Remember, you average the ranks. They get ranks of 18.5 each. So here's what you do. You take the sample sizes of each brand. So N sub 1 is the sample size of X, brand X, that's 5. N sub 2 is the sample size of brand Y, that's 6. And N sub 3 is the sample size of brand Z, that's 8. Then you just sum up the ranks, not the raw data. You sum up the ranks of X, sum up the ranks of Y, sum up the ranks of Z. So R sub 1, the sum of the ranks of X is 31. The sum of the ranks of Y is 52. And the sum of the ranks of Z is 108. If you can find these 3 sets of data right here, you've got this hypothesis test wrapped up. What's up? Okay, take your time ranking the data, in other words. Okay. All right, so the hypotheses. mu1 equals mu2 equals mu3. The brands all have the same average lifetime before recharging. Okay, and anytime you are comparing more than 2 groups, we always say as an alternative that simply HO is false. The brands have different average lifetimes. Significance levels 0.05. The test statistic, okay, this looks complex. It's not. It's capital H equals 12 divided by n times n plus 1 times the sum as I goes from 1 up to k of r sub I squared divided by n sub I, and then minus 3 times n plus 1. Okay, again, this looks complex. It is not. I promise you I'll explain this in just a moment because we're going to be doing this in just a moment. Okay, so first off, the assumptions. All right, each group must have at least 5 observations. All right, no big deal, at least 5 numbers in each. Independent random samples. Okay, the populations are continuous. That just means they can be ranked. They do not differ in dispersion. It doesn't mean that they have the same variance. It just means that they kind of look alike. If you went back to your analysis of variance test and looked at the assumptions there was a whole lot of baggage going on up in that piece. All right, there's not much going on here at all. Watered down assumptions for a watered down test. The decision rule. So check this out. Even though we're dealing with this capital H statistic, we are using a very familiar table, the chi-squared table. We're going to reject HO if H is greater than, and if you can't read that, that's chi-squared with k minus 1 degrees of freedom at the alpha level. And so there are 3 types of batteries, so 3 minus 1 is 2, for k minus 1 at the 0.05 level, and that's 5.991. If you need to practice, pause this video and go to your chi-squared table and practice that. Now, what did that H computation mean? So first off, N stands for the total piece of data. So N is the total sample size, which really is brand X plus brand Y plus brand Z. And in this case, if you add up, let's just look, 5 plus 6 is 11, and 11 plus 8 is 19. So just going back down right here, N equals 19. So it's 12 divided by N times N plus 1, which is 19 times 20. Then it's the sum of each group. You take each rank, square it. It was R sub I squared divided by N sub I. So you take the rank, square it, divide by its sample size. Take brand Y rank, square it, divide by brand Y sample size. Brand Z squared divided by brand Z sample size. Minus 3 times N plus 1, which is 20. Put it all together, and you get a computation. There it is. We're only going to reject if we get something that's greater than 5.991. Is 5.8 greater than 5.991? It is not. So we are going to fail to reject HO. We haven't done this in a long time. We're failing to reject HO. We're saying that brands X, Y, and Z all have the same average lifetime. So whenever you fail to reject HO, you give a best point estimate. So where did 28.21 come from? This is my advice once again. I've given it to you over the past 2 tests. I would take all 19 of these numbers, just not the ranks, the raw data. Take all 19 numbers, put them in L1, and then do 1 bar stats on that list on L1. That's how you can obtain this 2821. If you do that right now, pause this video and try it. Put all 19 numbers into L1, practice it and do that, okay? If you reject, what did we have to do for analysis of variance when you rejected? We had to use the Chaffee technique. Guess what? Awesome news. If we reject this non-parametric test, you are done. No confidence intervals, no Chaffee technique. Woohoo! You're done. All right, is there anything else here? Yes. All right, so this is the same as the Wilcoxon rank sum test if there were only 2 samples. Same exact test. All right, so there we go. All right, so bye-bye, everybody.